Hello and welcome back. In this video, we'll see how to solve given Boolean function using QM method with don't care terms. Okay, till now in the previous lectures, we have seen QM method for SOP equations without don't care. Now we're going to include don't care terms and try to solve the given equation. The procedure remains the same for the first table. Whatever is a min term, whatever numbers are mentioned, irrespective of whether they are min terms or don't care, arrange them in the proper order of increasing number of ones in their binary representation. Okay, you don't have to now worry about do I have to keep minterm separate from don't care or something like that. Just go follow the same order. Assume both the numbers as one set and arrange them. Okay, there's no change in the initial table, right? So we'll start with the least number of ones. There's no zero, so next it will be a single one. So you have 2, 0, 0, 1, 0. So 2 is done. 3 cannot be taken. I can take 4, 0, 1, 0, 0. 5, 13, 15, no. 8 is there, which has single 1. 9, 10, 11 cannot be taken. So group 1 is done with single ones. Next I'll go for 2 ones. So first is 3, 0, 0, 1, 1. Then you have 5, 0, 1, 0, 1. After 5 you have 9 here. So I'll go with this 9, 1, 0, 0, 1. Then you have 10, 1, 0, 1, 0. 13 has 3 numbers, 11 has 3 numbers, 15 has 3 numbers. So I'll have to go to next group. So next number after 10 I can take 11, which is 1, 0, 1, 1. Okay. Then I'll come here 13, 1, 1, 0, 1. And last group will have 15, 1, 1, 1, 1. Okay. So you are not bothering about whether I'm taking don't care or the minter. You're just assuming all of them to be a single set and you're taking it in proper order and arranging it here. Okay. So first column is done. Now coming to the second column, it is same. Combine those numbers which have only one position change. Okay. So we'll compare G1, G2 now. 2 and 3 can be combined. So I will get the answer as 0, 0, 1 dash. So 2 and 3 done. 2 and 5 not possible. 2, 9 is also not possible. 2 and 10 can be combined. It is dash 0, 1, 0. Okay, dash 0, 1, 0. So 2 is done. Next is I have to compare 4 with all these numbers. 4 and 3 not possible. 4 and 5 is possible. Sorry. So for 4 and 5, it will be 0, 1, 0 dash. So 4 and 5. 4 and 9, no. 4, 10, no. So next is 8 and 3, nope. 8 and 5, no. 8 and 9 can be done. 1, 0, 0 dash. So 8 and 9 done. 8 and 10 can also be combined. 1, 0 dash 0. Okay. So you're done with these two groups. Next we'll go for group 2 and group 3. So 3 and 11 can be combined, which is dash 0, 1, 1. 11 is also used. 3 and 13 cannot be done. 5 and 11, no. 5 and 13 can be done. 5 and 13, so it is dash 1, 0, 1. So 13 is also used now. Next, 9 and 11 is possible. 9, 11, 1, 0 dash 1. Okay. 9 and 13 is also possible. 1 dash 0, 1. Next, 10 and 11. Sorry. 10 and 11, which is 1, 0, 1 dash. 10 and 13 is not possible. So everything done with these two groups. Going to the last one. 11 and 15. Yes, you can make them as a group, which will be 1 dash 1, 1. And 13 and 15 can also be group 1, 1 dash 1. Okay. So you're done with the second column. And all the values from the first column have been used. We'll go for the further third column, binary, the min term and its corresponding binary. So compare the numbers which have dash in the same position. That becomes very easy for you. Instead of taking 2, 3 and comparing with all the values in the second set, only look for the number which has dash in the last position from here. Only compare with that number. Okay. So here I can compare 2, 3 with 10, 11 because they have dash in the same position. And as you can see, they have only one bit that is changing. So you can combine it. 2, 3, 10 and 11. So after combining, the reduced form becomes dash 0, 1 dash. So these two you have used now. Okay. Similarly, then I have this point I'll compare. They can be combined. 2, 10, 3, 11. I'll get dash 0, 1 dash. So this is done. I can also compare this with the 5, 13. Sorry. 2, 10 with 5, 13. But I have more than one change happening in this, so I cannot group them. Okay. So that grouping will not be possible. Next one we can try is 4, 5, 4, 5 and 10, 11. That is also not possible because you have more than one change happening. Then 8, 9 with 10, 11. Yes, you can combine 8, 9, 10, 11. The answer will be 1, 0, dash, dash. Okay. So 8, 9, 10, 11 will be covered. Next is this 8, 10 can be compared with this number 9, 11 and you can group it. So 8, 10, 9, 11. You will get the answer like this. So 8, 10 and 9, 11, 9, 11 are done. So all the values are covered. So close this group. Next you compare the second and the third one. So this cannot be compared with anything. Second also cannot be compared. The third one can be compared 9, 11 with 13, 15. You can combine. So 9, 11, 1 dash dash with 13, 15 done. Next 9, 13 with 11, 15 can also be done. 9, 13, 11, 15. So 1 dash dash 1. So 9, 13 and 11, 15 done. 10, 11, there is no value which can be compared with 10, 11. So that is done. You're done with the second column comparisons. Now, if you look at the third column, you have two groups, but you cannot compare any number because they don't have dash in the same places. So you further simplification cannot be done. You can stop here. And now we can start writing the second table, prime implicant table. Starting from the first column, look for the values which was not used. If this all are used, forget about it. Coming to the second column, you have one unused value here, then another one here. So make a note of both of them. First one is 4, 5, and they've given A, B, C, D. So the expression for this will be A bar, B, C bar. Second value which is not covered is 5, 13, and its expression will be B, C bar, D. Second column is done. Now coming to the third column, these two are single numbers, these two are similar number, and these two are similar number. You have total 3. So you can take 1, 1, 1 from this. 2, 10, 3, 11, which will be B bar C. Then you have 8, 9, 10, 11, which will be A, B bar. And the last one will be 9, 11, 13, 15, which is A, D. Okay. So now you have listed all the unused midterms in the second table. Next step, as I told you, write down the numbers. You just look at the question. you list it in this order now. First, you can list all the min terms followed by all the don't care terms. Okay. So the min terms, if I take, it is M2, M3, M4, M5, M13, M15. The remaining will be don't care terms M8, M9, M10, M11. Okay. Remaining terms are don't care terms. I am just arranging them in the exact way that they're mentioned in the question. I'm separating the don't care terms and the min terms for the second table. Okay. So next procedure is same. Put X under the numbers which are there given here in the prime implicant. First one is 4 and 5. Then you have 5 and 13. Then 2, 10, 3 and 11. Next is 8, 9, 10 and 11. Last one is 9, 11, 13 and 15. Okay. So you're done with all this. Next you have to circle. But now when you're circling the numbers, don't worry about the don't care terms. Don't circle the columns with single X in don't care section. Do it only for your midterm section. Okay. So here I have one, two, single X, there two single X. Don't circle these things. This is not necessary. Okay. Don't care does not have to be used for your output now. You have taken the help of don't care in the first table. So when you come to the second table, you can separate it and keep it as a separate section. And don't circle the columns with single X in the don't care section. Do it only for the midterm section. Okay. So now after circling the single X, you have to take the corresponding row value wherever you have circled X, which means you have 1, 2, and 3 terms. That is 1, 2, 3 term. So your output will be A bar B C bar plus B bar C plus AD. Last is confirmation step. So for confirmation, what you're supposed to do is whichever terms you have selected, the corresponding numbers you have to tick here. Okay. So I have selected A bar B C bar, so 4 and 5. 4, 5. Then I've selected B bar C. So number is 2, 10, 3, 11. Then the last number is AD and it is 9, 11, 13, 15. Okay. So now you just look whether these three terms have covered all the min terms given in the question. Don't worry about the remaining don't care terms. You have one which is not covered, but you don't have to consider it. This section is now completely out of your calculation. Okay. For finding out the final answer in this from the second table, you have to ignore the second half, that is don't care section. Okay. Just make sure that whatever equations you have written, whatever terms you have chosen for your final answer, those terms are covering all the min terms given in the question. If yes, then this will be your answer. Okay. So here M8 is not covered. You don't try to cover it using anything else. Okay. You just forget about it. But the min terms that are given in the question should be covered. If not, there is something else you have to do, which I will explain in the last part in the special case. Okay. I hope this is clear now. How we can use don't care. Now in the first table, I'll repeat again. Whenever you're writing the first table with the don't care, just arrange them in proper order of increasing number of ones, just like how you do for the other problems. Assume this to be one set and write the first table. But when you come to second table, separate the min terms and the don't care terms and forget about the don't care section and only do or continue the process with the min term section. Okay, and solve it. So I hope this is clear. We can try solving one more question so that becomes more clear. I can give you the data. You can pause the video, try to solve it on your own, and then you can get back and verify your answer. Okay. So let's just take some random number here. So let's say we have 2, 3, um, 5, 7, 9, 11, 13. With don't care terms 0, 1, 8. Okay. But now, what is the difference here? The question, whatever is given, is not SOP, it is POS. And you have not learned how to solve POS equations using QM method. Okay. There is no need to learn any new table now. All you can do is, even if POS is given in the question, you convert it into SOP and then solve it as usual. Okay. So how do you convert POS to SOP? Whatever numbers are mentioned in the POS equation, take the numbers which are not there in this and not there in don't care. Okay. Don't care is 0, 1, 8. Don't touch them. Don't touch these three numbers. Apart from these three and apart from whatever is given in the POS max terms, remaining number should be written here. Okay. So here, if I see 0, 1 is not there, but it is already covered in don't care. So I cannot put it in SOP. Don't write 0 and 1 in this. Okay. Next, you have 3. 4 is not there. You can list it. 5, 6, 7, 8, 9 is there. 10, 11, 12, 13, 14, and 15. So you see, I have not used 0, 1, and 8 in the SOP equation. So that will be kept as it is. Don't touch the don't care terms. Only make sure that whatever numbers are not there in both of them, you're putting it in POS, SOP or midterm equation. Okay. So now you have the problem in the format which you have learned how to solve using QM method, right? Further procedure remains the same. So we'll start now. Midterm. This is binary. So arrange it. Look for the lowest number first. Okay. Lowest number is in don't care. Start with that number 0. 0, 0, 0, 0. Done. This is one group because all there is no 1 at all. So this becomes a separate group. Next number you have is 1, which has 0, 0, 0, 1. Okay. Then 4 also has single 1. 0, 1, 0, 0. 10, 12, 14. 8 has single 1. 1, 0, 0, 0. Whichever has single 1, put it in order. Okay. So you are done with 4, 0, 1, and 8. Next is 6, which has two ones. 10 also has two ones. 12. So 14 cannot be taken. 14 will be next group. 1, 1, 1, 0. And now last group is 15. Like this. Okay. Next we'll do the combination. Big term and binary. 0 with 1. Yes. Can be combined. Done. Then you have 0 with 4. 0 dash 0, 0. And 0 with 8 is also possible. Yeah. Okay, this grouping is done. Next, 1 with 6, no. 1 with 10, no. 1 with 12, no. Cannot be done. 4 with 6, yes. 4 with 6, 0, 1 dash 0. 4 with 10, no. 4 with 12, yes. Dash 1, 0, 0. Okay, next. 8 with 6, no. 8 with 10, yes. 1, 0 dash 0. 8 with 12, yes. Can be combined. Okay, this group is also done. Next, 6 with 14, yes, it can be combined. Dash 1, 1, 0. 10 with 14 can also be combined. 1 dash 1, 0. 1 dash 1, 0. 12 with 14 can also be combined. 1, 1 dash 0. Okay. And then last is 14 with 15. It can be combined. 1, 1, 1 dash. So from first column, all the numbers are used. I will go to the second column combinations and put the combined groups in the third column. So compare this. There is no term which has a dash in last position, so I cannot use 0, 1. It will be left as it is. Coming to the second term, this can be compared with this number, correct? Because they have dash in the same places. So and also I can combine it because they have only one place change happening. So 0, 4 with 8, 12, and the answer will be dash dash 0, 0. This and this are done. Okay. Now this number can be compared with this number. 0, 8, 4, 12, dash dash 0, 0. These two are also covered. This grouping is done. Next, we'll go for this and this comparison. I have to now compare 4, 6 with 12, 14. 12, 14 can be done. 4, 6 and 12, 14 dash 1 dash 0. Done. Then first place 4, 12 with 6, 14. That is these two. This and this. Okay. Next, 8, 10. You have this 8, 10 and 12, 14. 8, 10 and 12, 14. You'll get 1 dash dash 0. 1 dash dash 0. And then 8, 12, 10, 14. 8, 12, 10, 14. Dash 0. So all are done. Coming to the last group. There is no possible way of combining this with anything because you don't have any number with a dash in the last position to compare. Okay, so I'll have to stop this part here. Now further, if you can compare these two, you can, but you see, you don't have any number with same dash positions in these two groups. So further simplification is not possible. You have to go to the second table. So second table, first step is list out all the prime implicants. So we'll start with first column. There is no unused term. Go to second column. You have one unused term here. It is 0, 1. Write it here. Its corresponding value. If I give it in, I've given the question in WXYZ format. So this will be W bar, X bar, Y bar. Okay. Then there is this term which is not used, which is 14, 15. So it is W, X, Y. Coming to the third column, you have this number which is not used. 0, 4, 8, 12. They are same, so write it only once, okay? Which is not there, Y bar, Z bar. The next one will be 4, 6, 12, 14, which is X, Z bar. The last one is 8, 10, 12, 14, which is W, Z bar. Okay. Now you have to write only, you have to separately write the minterms and the don't care. Okay. When you come to second table, you put the don't care on one side, minterms on the other side. Now, when you're writing the minterms, please make sure you're not writing what is given in the question because it was in POS. You're writing whatever SOP equation you have got. That is, you will have to write this one. Okay. So it will be M4, M6, M10, M12, 14, 15. And the don't care terms M0, M1, F8. Okay. I'm separating these two sections. So now we'll put X 0, 1. This is 14 and 15. Then you have 0, 4, 8 and 12. 4, 6, 12, 14. You have 8, 10, 12, 14. So when you circle the single X, it should be only for the minterm table. This, and here. Okay, don't worry about the don't care terms, just ignore them. Now we have corresponding row for the circled x are these three. So your equation will be wxy plus xz bar plus wz bar. Now for the final verification step, these three equation numbers should be ticked 14, 15. Yes. Then 4, 6, 12, and 14. Yes. And the last one is 8, 10, 12, 14. So with the three terms, you were able to cover all the given numbers of the SOP. So this will be your final answer. Don't worry about these two remaining terms which are not covered, okay? Because they come under don't care. So you don't have to bother about this. Just make sure that all the terms from the min term section is covered. If yes, then whatever terms you have written here, that will be your final answer. Okay. So I hope this part is clear with QM method using don't care. So now just we'll take one last question, which is the special case. Till now, I've told you, in the final confirmation step, you had to make sure that all the midterms given in the question were covered. And till now, we have seen problems where that was happening. Now, what if you get a question where in the final confirmation you see some midterm is left out? It was not covered. What is that additional step you'll have to do to get the final answer? Okay, so we're going to see that question now. So let me take a three variable for easy, for a quick completion for you to understand it well. I'm taking a three variable function, okay? ABC 03467. Now, I'm not taking any don't care terms here. This is without don't care, simple problem. So we'll just quickly do this. I think the first part and till the second table, you can do it yourself. Pause the video and please complete the problem, okay? And when you come to the last step, I'll let you know what to do. So you can quickly finish this. Now it is only three variables, so don't put four zeros here. Don't take 4 bits, okay? Only 3 bits, A, B, and C. Okay. This is one group with I'm so sorry. This is one group with 0 1s. Next comes there is 4 which has single 1 in it. Zero, zero. The next group will be 3 1 0 1 1 6 1 1 0 and then 7 1 1 1. Okay. You have to know the binary format of these numbers so that you will know which number has how many ones in that binary representation. Okay. So next column combination 0 with 4 can be combined and the answer will be dash 0 0. This is done. One group is done. Next these two. 4 and 3 is not possible. 4 and 6 is possible, which will be 1 dash 0. So 6 is done. This is also done. Next, 3 with 7, possible, dash 1 1. 6 with 7 is also possible, 1 1 dash. So you're done with the second table also. And see if you can do any combination here. No. Any combination from here to here? No. Further simplification is not possible in this. So your final table will be, the second table will have, from here everything is covered, but from here you have all the 4 terms which is not used. So list out all of them. 0, 4, this will be B bar C bar. 4, 6, A C bar. 3, 7, B C, and 6, 7, A B. Okay. Now list out the minterms M0, M3, M4, M6, and M7. We'll put X now 0, 4, 4, 6, 3, 7, 6, and 7. And circle single X. 2, 2, 2. Only 2 are there. So 2 rows will be there in your equation. But one is B bar C bar, other one is BC. Now for the final confirmation, pick the numbers which are there in these two equations. B bar saver is covering 0 and 4, so M0, M4. This is 3 and 7. Sorry. Now you see there is one min term that is left out, which is not covered with only these two terms, which means this cannot be a final solution. You will have to add one more term to your answer so that this M6 can be covered. Okay. And how do you do that? Under M6, you have two x, right? So now you have two options. Either you consider this x and take the corresponding row value, write it in your answer. So your answer will be A, C bar, which means along with the essential prime implicants which you have already written, to cover M6 you need additional term, and that term is obtained by taking the x which is there in the M6 column. Okay. If you have 3x in the M6 column, out of 3, you can choose any one of them and write its corresponding row equation in your answer. Okay. If at all I had chosen uh, this x, then my answer. Okay. If I had chosen this x, then the answer would have been p bar c bar plus bc as it is. For this x, the corresponding row value will be ab. Okay, so based upon which x you're choosing under M6, your answer can be either this or this. Both are correct. So in your exam, when you get such questions, you have a choice to write either this or this. What I'm trying to say is, if any midterm is not covered, you, there will be some x under that midterm, right? You can choose any one of the x under that midterm. If there are all four x here, you can choose either this or this or this or this. Out of four, you have one option. Any one of the four can be taken and written in the solution. Okay, this is the special case. What you have to do if any midterm is not covered by the original output you have taken, in which case your output becomes incomplete. You will have to add additional term there. And how do you take that term? Which one is not covered? Under that, you will be having some x. You can take the row value corresponding to any one of the x from there. Okay, so this will be your solution. For this question, you have two possible outputs based upon which x you're going to consider. Both are correct. Either you can write this or you can write this. Even better, whenever you get such problem, you write all possible outputs for the question. Okay, so I hope this is clear now, and this completes the QM method problems. We have done both with and without don't care condition, and also I have shown you how to do the special case, how to solve the special case problem. Okay, thank you.